Once again, good evening. Welcome to this Unacademy CAT for MBA channel. And in this session, we are going to discuss remainders and cyclicity. Yes, so we are moving towards our mission, that is CAT 2020. We want to crack CAT exam, and this is where on this channel I'm going to help you to do that. Not only me, but our team of educators will be helping you out for that. So let me quickly introduce myself. My name is Ronak Shah, and this is my background. So I have been training students for 12 years, and I've trained more than 10,000 students for CAT and other entrance exams. Not only the preparation of quantitative ability and LRDI subjects, but I've also guided them for the strategy, and I've also mentored them for colleges and admissions. Yeah, and we have the best of the educators to help you out to prepare for this various entrance exams. Right, so please make sure that you have subscribed to our channel and you be here daily live for this classes. Right, and just to quickly brief you about our agenda of this session, so we are going to discuss we are going to quickly revise the concepts that we discussed in the previous session. Yes, this is lecture number 6 of number systems. So we have discussed already many concepts in the previous sessions. In case if you have missed that, then please refer to our playlist of number system and you'll find all those sessions over there. Right, so we are going to revise those concepts of number system, remainder concepts, and then we'll look at Euler numbers, which is very important concept. Then we'll look at some remainder questions, and we'll understand the concept of cyclicity. So cyclicity is used when you want to find out last digit, and this kind of questions where you need to find out last digit of say 2 raised to 50 or 132 raised to 100, and you need to find out last digit. So this kind of questions are asked frequently in various entrance exams. So this is what we are going to learn today, right? So let's quickly go ahead and yeah, once again, good evening everyone. Varshini, Rajat, Nicole. Right. So quickly tell you about our YouTube channel. So you are watching this daily live on Unacademy CAT for MBA, and if you haven't subscribed to that, so please do it quickly. Do not forget to press the bell icon so that you can get notification about my sessions. And we also have Telegram channel by the name CAT for MBA. Right, in case if you want to conquer your preparation, then I will recommend you to go for the subscription plan. So we have our Unacademy platform also, where we conduct various courses related to this MBA entrance preparation, and that would definitely enhance your preparation. Not only that, you also get access to test series and various other benefits. Right, these are certain plans that we have. I'll always recommend you to go for this 12-month or 24-month plan. These are the pricing, and in case if you go for this, do not forget to apply my referral code so that you can follow me over there as well, and you can also enjoy 10% discount. My referral code is SHAH10. Do not forget that. And yeah, so let's quickly begin. Yeah. So this is what we had discussed earlier, remainder concept. So in that I had given you very simple example that if you take a number 94, when you divide it by 8, the remainder is 6. In fact, 94 can also be written as 50 plus 44 or 47 into 2, and if we ultimately divide by 8, we got remainder as 6. So in case if you miss out this concept, please refer to lecture 5 video of number system so that you can quickly recollect. Then we discussed this negative remainder concept, very important as far as this remainder questions are concerned, especially high power remainder questions are concerned. So for example, if I ask you 9 divided by 5, what is the remainder? So you can say it's 4 or minus 1. So both of these are correct. So this is how you can use concept of negative remainder. Yeah, and so one thing that I'll always suggest you to remember, in fact this is the thumb rule that you can use in the high power remainder questions, always try to get remainder as 1 or minus 1. Okay, so this is where this negative remainder concept came in the picture, that we will try to simplify, we can simplify the calculation if we can use this concept of negative remainder. So I had also given you the examples earlier. So say for example this question 8 raised to 31 divided by 7, you can quickly get 8 divided by 7, remainder is 1. So now my question is 1 raised to 31 dividing by 7, so of course remainder was 1. Same way 6 raised to 20 divided by 7, so 6 is 1 less than multiple of 7, 7 ones are 7, so 6 leaves remainder minus 1 when you divide by 7. So now my question is minus 1 raised to this 20 power, minus 1 raised to 20 power, and finding the remainder. Same with 13 raised to 20 divided by 7, still we can say 13 leaves remainder minus 1 when you divide it by 7. So ultimately we can quickly solve these questions. So these are the few questions that we discussed earlier, right? I'm sure you remember all these questions that we had discussed earlier. Then we also discussed that concept of, we also discussed various remainder theorem. The first one was Fermat's little theorem, which says that a raised to p minus a is completely divisible by p, where p is a prime number and a should be less than p. Okay, so I have also given you one example that 2 raised to 7 divide by 7, remainder will be 2. Okay, see, there are two concepts here. A raised to p minus a is completely divisible by p, so a raised to p leaves remainder a when divided by p. So we had discussed both of this concept. Okay, concept number 1 and concept number 2, right? So I have also given you the example. Let me just rewrite here. 2 raised to 7 divide by 7, remainder will be 2 as per this second rule. Look at the second rule. Same way, 2 raised to 7 minus 2 divide by 7, remainder will be 0. If you want, you can verify this thing. It will be completely divisible by this one. The 7 has to be the prime number. The power has to be the prime number, and you are also dividing by the same power. Okay, that is p. Then we also discussed this Wilson's remainder theorem, which says that p minus 1 factorial divided by p, the remainder will be p minus 1. I've also given you the example. You can apply, you can verify that thing. Of course, the mathematician has found out this thing, so it must be true, but just for your understanding, you can apply it in the situation and you can understand that. Yeah, hi Nicole and Arunima, hi Shubhankar. So then we also discussed this Euler's remainder theorem. So we skip that part, but you can just remember that for timing, because we are going to discuss these Euler numbers in detail, right? So that's where we'll apply this concept. And then we had also discussed this special case. I'm sure you must have noted down this thing, that a raised to m divided by 2a, it will leave remainder a if a is odd. And b raised to m divided by 2b, remainder will be 0 if b is even. Now I have given you two examples. This first rule can be applied over here, and the second rule can be applied over here. So this number 6 is an even number, so 6 raised to 17 divided by 12. Okay, now this power can be anything. It can be any power, okay, except 1. So this is going to be completely divisible and remainder will be 0. The simple reason is, see, if you take 6 square is 36. Can I say 36 is completely divisible by 12? So remainder is going to be 0. Now if you take any higher power of 6, it's going to leave the same 0 remainder, right? It will be completely divisible. So that's the point. Same way, if you take any odd number and if you raise to any power and if you divide by twice of that number, that is 5 2s are 10, I'm dividing by 10, so this remainder will be surely 5, right? Or you can take another example, say 7 raised to 51 divided by 14, the remainder will be 7 itself. So have you all understood this part, everyone? Yes, are you all with me? Fine, guys. So now before we go ahead, so this is what we had discussed in the previous session. Before I go ahead, would like to tell you once again about my special classes that I conduct on Unacademy platform. For that, you should have just downloaded the mobile app and you need to follow me by the name Ronak Shah, or you can also check by the name Ronak Kumar Shah, right? So you follow me over there and you will be able to attend all my special classes. You will get updates about that. I'm going to soon conduct a marathon session. In fact, on this 5th of July, everyone, please remember this thing. Please mark this date in your calendar. On 5th of July, I'm going to conduct a 4-hour session on this as a special class. You don't need to avail any subscription for that. You just need to download this app and follow me over there. Just press the follow icon. Okay, so I'm going to conduct a 4-hour session on arithmetic, so please be there. And even I'm going to conduct a revision session for number system maybe on Saturday once the concepts are over. Okay, so now let's understand this Euler's numbers. What are the Euler numbers? Okay, and then we'll look at the Euler remainder theorem. So Euler numbers are represented by phi of n, and the formula for this is n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c, and so on and so forth, where a, b, c are the prime factors of n. So when we represent n in this form, in the prime factorized form, a raised to p into b raised to q into c raised to r and so on and so forth. So of course we know what are the prime factors of n, and then we can find out phi of n. Now what this phi of n represents? So this represents number of numbers less than and coprime to n, less than and coprime to n. So for example, if I ask you how many numbers less than 30 are coprime to 30, 30 से छोटे ऐसे कितने numbers है जो 30 को coprime है? So that is represented by phi of 30. Okay, and let's find out. In fact, we had solved this question earlier also, maybe in second or third session when we were discussing divisibility, HCF, LCM, prime factorization and all. So I had mentioned this point. I'm just elaborating on that. So this phi of 30 represents number of numbers less than 30 and coprime to 30. So this can be found out using this formula: 30 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. Why? So because if you prime factorize 30, you know what is the prime factorization of 30? So prime factorization of 30 is 2 raised to 1, 3 raised to 1 and 5 raised to 1. So which are the prime factors of 30? 2, 3 and 5. So 30 into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. Okay, so if we just solve this thing, what is 1 minus 1 by 2? It's half. 1 minus 1 by 3, it's 2 by 3. 1 minus 1 by 5, it's 4 by 5. So we can simply solve this thing. Of course, this is going to be 30, right? So this will get cancelled off. So what are you left with? 8. So there are 8 numbers less than 30 which are coprime to 30. Let me quickly tell you which are those 8 numbers which are coprime to 30. Numbers which are coprime to 30 and less than 30. So these numbers are 1, then 2, 3, 4, 5. All of these are not coprime to 30. Directly it will be 7. Then which number will be there, guys? 11. Of course, even numbers cannot be coprime, and the multiple of 3 cannot be coprime, and the multiple of 5 cannot be coprime. So I'm picking all the other numbers. So 1, 7, 11, 13. Then definitely it will be 17, 19. Are you getting this point, guys? Then 23 and 29. So these are those 8 numbers: 1, 2, 3, 4, 5, 6, 7 and 8 numbers, correct? So this is how you can quickly calculate number of numbers less than and coprime to n, that is represented by phi of n. So it came out to be 8 numbers. Have you all understood, guys? Show me a thumbs up, guys, quickly. And yeah, do not forget to press the like button. That's a compulsion, that's a mandatory thing. Yes, great. Okay, so now let's see what is the Euler's remainder theorem. I'm sure all of you have understood this. If you want, you can quickly note down this thing. The first is, of course, formula. You should have noted down this formula, and of course you remember this prime factorized form, correct? And yeah, so I'm sure you have understood this part as well. Phi of 30, how did we calculate, how did we use this formula? And I have also shown that why are there 8 coprime numbers, or what are those 8 coprime numbers? So we could found that as well. Yeah, hi Robin, good to see you. Great. So where is Rajat and where is Harsh? Where is Prashant? Okay, fine, guys. So I hope you have understood these concepts. Now let's look at what is Euler's remainder theorem. So this is the Euler's remainder theorem. So a raised to phi of n divided by n, remainder will be 1. Let me give you one example. Okay, once again here n can be any number, a can be any number. The only thing is a and n should be coprime. Remember, there should not be anything common in a and n. So I can't take 6 raised to 10 divided by 10. I can't do it this way because 6 and 10 are not coprime. So I'm sure you all remember what are the coprime numbers, by the way. Okay, so let me give you an example of this situation. So if I take 2 raised to 5, okay, now please understand 5 is a prime number. Any prime number has always one less coprime to that. So for example, how many numbers are coprime to 5? Less than 5. Okay, so 1, 2, 3, 4, all of these are coprime to 5, isn't that? So if I ask you how many numbers are coprime to 13, how many numbers are coprime to 13? So there will be 12 numbers, right? So here 2 raised to 5, Just a moment. Here, it should be phi of n over here. So 2 raised to 4 divide by 5. This remainder will be 1. Because for phi, if we take n as 5, so number of coprime to 5 less than 5 are 4. So 2 raised to 4 divide by 5, remainder will be 1. Are you getting this point? So you can straight away apply this concept and you can solve questions. Of course, we are going to practice plenty of questions based on remainder today, and we'll apply this concept as well over there. Just you need to recollect that. Okay, this is here we can directly apply that Euler's remainder theorem. Are you all clear with this point, everyone? Yeah, great. So let's take one more example. Suppose I give you this kind of question, something like let me take this one. 7 raised to 16 divided by 15. What is the remainder? Everyone, 7 raised to 16 divided by 15. What is the remainder? This is the question. Okay, please pay attention here. Now, first of all, let's quickly understand how many numbers are coprime to 15. So what is phi of 15? What is phi of 15? So 15 is made up of which prime numbers? It's made up of 3 and 5, isn't that? Okay, so it should be 15 into 1 minus 1 by 3 into 1 minus 1 by 5, right? So if you just solve this thing, it's 15 into 2 by 3 into 4 by 5. So it will come out to be 8. There are 8 numbers less than 15 which are coprime to 15. You all agree with this, everyone? So that means if there is 8 power over here, if the power is 8, then of course 7 raised to 8 divided by 15 is going to leave remainder 1. So can I write down this as 7 raised to 8 whole square divided by 15, everyone? Are you with me? Have you understood this part? See, I am applying this Euler's remainder theorem. Okay, so Euler remainder theorem says that there should be phi of n numbers over here. The number in the power should be phi of n if this is the n. Okay, so for 15 we found out phi of n, then that is number of coprimes less than 15. Okay, so it's 8. So I can write this 7 raised to 8 whole square. This is going to be nothing but 16. Now 7 raised to 8 divided by 15, remainder is going to be 1. If you want, you can check it on calculator. Find out 7 raised to 8, add 1 to that, and then divide it by 15. You will get, subtract 1 from that and divide it by 15. You are going to get remainder as 0, because calculator will not show you remainder 1. So this is another way of verifying. So here you are going to get remainder as 1. Yes, guys, have you all understood this? The Euler remainder theorem. Okay, so let's look at some questions quickly. Find the remainder when 13 raised to 91 is divided by 9. Everyone, 13 raised to 91 is divided by 9. So we need to find out remainder over here. So let me solve this question because few of you are new to this thing. Okay, so let me quickly help you understand how to solve this question. So 13 raised to 91 divided by 9. First of all, what is the remainder when 13 is divided by 9? Of course, the remainder is 4. So now my question is 4 raised to 91 divided by 9. Now find out a power of 4 which will leave remainder 1 when you divide by 9. So can I say 4 cube is 64 and 64 divided by 9, remainder is 1, correct? So here we can represent this 4 raised to 91 as 4 raised to 3 whole raised to 30 into 4 raised to 1, because we need to get total 91 power, correct, everyone? Yeah. So, and we need to divide this 1 by 9. Now 4 cube is 64, 64 divided by 9, remainder is 1. So 1 raised to 30, it's going to be 1, correct? So this part remainder came out to be 1 into this 4 itself, divide by 9. So of course your final remainder is 4. Have you all understood all the steps? If yes, then show me a thumbs up quickly. Show me a thumbs up. Everyone, whosoever is present. Yeah. So quickly note down this point and then try for the second question. Yeah, great. Yes, what about others? Fine guys, so try for this question now. 12 raised to 40 divide by 25. 12 raised to 40 divide by 25. Okay, now here we can directly apply that Euler's remainder theorem. Euler's remainder theorem. We can directly apply this Euler's remainder theorem. How? Let's understand. What is phi of 25? Now please understand 25 is made up of only this prime number 5, right? So in the prime factorization of 25, you will just see one prime number, that is 5. So phi of 25 is nothing but 25 into 1 minus 1 by 5. As simple as that. If you solve this, this will come out to be 20. So phi of 25 is 20. So if I somehow make this power as 20, of course that will leave remainder 1 when you divide by 25. Yes or no? Because these two are co-prime C. Okay, and so this can be written as 12 raised to 20 whole raised to 2 divided by 25. Now this part divided by this part will leave remainder 1 and 1 square. So now it's 1 square divided by 25, of course, so remainder will be 1. Have you understood this? We applied that Euler's remainder theorem, correct? Yeah, great. So guys, there are a few more questions for you. This one, tell me what will be the answer over here. I have given you a theorem which you need to apply over here. Which theorem will be applicable? Can you quickly tell me? Yes, guys, can I apply this rule? B raised to m divide by 2b, remainder will be 0 if b is even. B is an even number. So straight away the remainder has to be 0 over here. You can try it. I mean, it's very simple thing. 12 square is 144. 144 divided by 24, remainder 0. So now if you take any power more than 2 also, well, any power more than 2, it will leave remainder 0 when you divide it by 24. As simple as that. So this is the rule that we applied. Okay. Right. So answer over here is 0. The remainder is 0. Same way. Okay. Same way, had it been something like this one, 17 raised to 54 divide by 34, the remainder will be straight away 17. Please remember this point. The remainder will be straight away 17 because this is an odd number and we are dividing it by twice of this odd number. So straight away remainder will be 17. Correct? Yes, guys. So see, gradually you are getting good grip on this one. The only thing is you will have to remember this point, guys. And the simple way to remember it is periodic revision, because otherwise you are going to forget this within a week's time. Not even more than that. You will not even remember what was the Fermat's little theorem, what was the Wilson's theorem, what was the this one Euler's remainder theorem, or what is that rule when we divide a number by twice of that number. Right, so all of these points you will have to remember, and for that you will require periodic revision. So keep doing it. And of course, yes, so if you are there, if you are attending my special sessions and regular YouTube sessions, so it will be taken care, because periodically we'll conduct these revision classes either on YouTube or on Unacademy platform during the special classes. So I'll shortly announce the schedule for next 10 days, next 10 special classes, so you can check what I'm going to teach over there. In fact, from tomorrow I'm starting with time, speed, distance. So we are going to complete time, speed, distance in about 4 sessions. Okay, so Thursday, Friday, Saturday, and then Monday. So we'll complete this time, speed, distance, and on Sunday we are going to have a marathon session. Okay, 4-hour session straight away. So it will be mostly on arithmetic, but I'll still decide. So you can also suggest me the topics. If you want, you can write the topics over here in the chat box, or when you attend my this special session, you can also provide your suggestion over there, Kisanda. So please do the revision of this one, and we'll do that way. Okay, so guys, about this one, now let's try to solve this question. This is a slightly tricky question, so unless you have practiced these questions earlier, probably you will not get the idea. But still, if you want, you can just try to figure out something. Sir, how to distinguish easily between Eulers and special? Okay. See, Shubhankar, Eulers will be the last option. I'm sure Eulers is not going to come to your mind, because how can you quickly think? For example, if I give you a question like this one, 37 raised to 45 divide by something, say 60. Now 60 or 75 or something like that. Now it may be possible that for 75 the Euler number may be 15. You will have to do that calculation. So we will not apply Euler theorem unless we do not find any other way. So first we'll try to get the remainder 1 or minus 1. If that's happening, we can quickly apply, and that would happen mostly when you have smaller number in the base over here. If the base number is smaller, something like 4, 5, 6, 7, 8, 9, something like that, you can quickly think of power of that number, which will leave remainder 1 or minus 1 when you divide by the divisor. But if you have bigger numbers over here and bigger number over here, then you will have to think all these things, whether you can apply Euler or some other theorem. Are we clear? Right. So special case is very simple. A raised to n divided by 2a. Remainder will be either a or 0. A कब आएगा when it is odd. 0 कब आएगा when a is even. A is odd, a is even. Okay, these are the two cases. Very simple. I mean, you can easily make out. 17 divided by 34 or 7 divided by 14, something like that. This is a special case. Are we clear, guys? Fine. So let's try to solve this question. Now see, here you will have to apply that formula, algebraic formula. A cube plus b cube is equal to a plus b in the bracket a square minus ab plus b square. Yes, we will use this over here. So let's quickly look at that. Now here you will have to make some observation. Everyone, listen to me carefully. 16 plus 19 is 35. Okay, so if I write it this way, 16 cube plus 19 cube. And when I factorize it, of course, one factor will be a plus b, that is 16 plus 19. It's going to be 35, which is half of 70. Same way, 17 plus 18 is also 35. See, please understand, this is CAT question. I don't remember the exact year. Maybe this kind of question has been asked a couple of times, if I'm not wrong, in past 12 years. At least I have seen this kind of question twice. Okay, maybe with different numbers. So this is a CAT question, by the way. Yeah, hi Akash. So what I'll do is, I have made pair of this one, and same way I'll pair this and this one. So it will become 17 cube plus 18 cube. Now let's solve this part. So this will be 16 plus 19 in the bracket 16 square minus 16 into 19 plus 19 square. This is first part. Okay. Plus, let's solve this one. So it will be 17 plus 18 in the bracket 17 square minus 17 into 18 plus 18 square. Correct? Okay. Now guys, what you need to tell me is, of course we don't need to solve all this part. We don't need to solve. The first thing is, this is 35, this is 35. So can I take out 35 as the common factor? Yes. So I can write this one as 35 in the bracket this part plus this part. Yes or no? Very simple. Okay. Tell me whether this part is going to be odd or even. Is this odd or even? Can I say this is going to be odd number? Because this term is even, this term is even, and this is odd. So even minus even plus odd, it's going to be odd, right? So that's why I'm going to get odd number over here. Plus, same way, if you look at this one, odd, even, even, it's going to add or subtract up to an odd number only. Can I say odd plus odd is nothing but an even number? So ultimately this bracket result is going to be an even number into 35. Now any even multiple of 35 is of course completely divisible by 70. Yes guys, any even multiple of 35 is going to be completely divisible by 70. So what will be the remainder over here? The remainder will be equal to 0. The remainder will be equal to 0, as simple as that, when we divide this one by 70. Understood guys? Show me a thumbs up if you understood this question. Now you may come across different similar questions. I mean, different questions based on the same concept. You should be able to figure out. So here we have applied that a cube plus b cube funda. You may have to apply something else, something like a square minus b square or any other formula. Are we clear? Right, great. Fine. So if you want, you can just note down the steps. Guys, you will have to keep noting down the steps when I'm explaining that. Listen to me as well as keep noting down those steps. Okay. If you have some more time, then what you can do is you can just listen to me here and understand the concept and just write down important points. And once the session is over, you can quickly watch the video once again and then note down those steps one by one manner. But that will be slightly more time consuming process. Yeah. Looks complicated, but it's not, isn't Varshini? That's correct. So it's just that we haven't discussed anything related to algebra right now. We are just talking about numbers. We have been discussing only numbers. So the moment we look at algebraic formulae, it will start coming to our mind, right? And we would not find things very difficult in totality once we'll conduct the revision sessions once the syllabus is over. So don't worry, it would be taken care. Okay guys, so let me give you one more question, right? One more question. How many odd perfect squares from 1 to 1000 are not divisible by 3? Again a cat question. Again a cat question. These questions look very simple, one-liner, but then they are slightly more detailed. How many odd perfect squares from 1 to 1000 are not divisible by 3? Tell me one thing. My first question is how many perfect square numbers are there between 1 and 1000? How many perfect squares are there? Can you tell me? How many perfect square numbers are there between 1 and 1000? Everyone, can you think of? Type the answer in the comment section. Chat box, quickly. Can I say there are 31 perfect square numbers? Yeah, 31 perfect square numbers, because 30 square is 900, 31 square is 961, 32 square. Now please understand, 32 square is nothing but 2 raised to 10. And if you remember that power of 2 up to 10, you can easily make out this is 1024. So it's going to be more than 1000. So all the numbers, square of all the numbers, 1 square, 2 square, up to 31 square, they'll be less than 1000. Correct? Fine. So we have 31 perfect square number. And which are this 31 perfect square number? 1 to 31. Can I say out of this 31 perfect square numbers, 16 numbers will be odd and 15 numbers will be even? Which are those even perfect square numbers? 2 square, 4 square up to 30 square. So these are 15 even numbers. We don't need to look at them. We just need to look at odd perfect squares up to 1000. So that means we are talking about this 16 numbers. Yes, we're talking about this 16 numbers. Correct, guys? Yep. Okay. Now, out of this 16 numbers, how many are not divisible by 3? Now, which are those 16 numbers? Let me just write down for your information. This is 1 square, then 3 square, 5 square, 7 square, up to 31 square. Can I say out of this number, this 3 square, then 9 square, then 15 square, 21 square, and 27 square, all of these are divisible by 3. So we need to exclude them. 1, 2, 3, 4 and 5. We need to exclude these 5 numbers. That's it. So our answer is 16 minus 5, that is 11. This is the answer. As simple as that. Okay. In fact, you actually don't need to do all these things. You don't need to count it this way. Just because these 16 numbers are in pattern, 1 square, 3 square, 5 square, 7 square, they are in pattern. Whenever the numbers are in pattern, if you want to find out how many of them are divisible by 3, what you can do is you can simply divide 16 by 3 and you can get the answer. You will get something like 5 point something. Now check whether it's less than 5.5 or more than 5.5. So this is less than 5.5, so it has to be mostly 5 numbers, unless the starting and the ending number both are divisible by 3. So here that's not the case. So we can straight away make out this is going to be 5 numbers. We need to exclude those 5 numbers which are divisible by 3. So we'll be left with those 11 numbers. This is our answer. Yes guys, have you all understood this part? Correct? Fine. Are you all enjoying the session? Everyone? Fine. Show me a thumbs up quickly. And yeah, do not forget to press the like button if you have just joined. Yeah, the first thing that you should do when you join this session, press the like button. So you don't need to listen to my instructions about like button. That's the policy of this channel. Okay, great guys. So let me give you one more question. Now I want you to think about this, everyone. I want you to think about this question. 48 raised to 45. 48 raised to 45 divided by 81. Tell me what will be the remainder. Anyone? If you can answer this question with the correct logic, I can bet you are going to get 90 plus percentile right away. If you can answer this question with the correct logic, you are going to get 90 plus percentile right away, I can tell you. Yup. Type your answer in the chat box quickly. Type your answer in the chat box. How will you solve this question? It's a very simple, very conceptual question. Okay, yeah, Robin, thanks. Shared class link to some groups. I'm sure your friends will benefit not only from me but our other faculties, because they are just best of the faculties. I mean, they have been teaching to the students and students have enjoyed their methodology. It's not an overstatement, honestly. Only when you will attend the session you will come to know. So for example, if you have attended today Mr. Rishikesh Kate's session, you would have seen that the way he teaches, he connects very well with the students. And I know him, Mr. Rishikesh Kate or Mr. Shyam Jagrut or Apurva madam. I know all of them for last 3-4 years, right? No, answer is not 3. The answer is 0. The remainder is 0 because this is perfectly divisible. Let's understand, guys. Pay your attention. Let's understand. What is 48? Can I say 16 into 3 is 48? So this is 16 raised to 45 into 3 raised to 45 divided by 81. What is 81? 3 raised to 4. Can I say 3 raised to 45 is completely divisible by 3 raised to 4? Of course. Isn't that 3 raised to 45 is completely divisible by 3 raised to 4? When you divide 3 raised to 45 by 3 raised to 4, your quotient will be 3 raised to 41 and the remainder will be 0. So since this part is completely divisible by divisor, of course the complete number is completely divisible by the divisor and the answer has to be 0. So when you are given such questions, guys, you should be able to figure out, right? Okay, what's the clue? For example, let me give you one more example. 34 raised to 34 divided by 8. What is the remainder? 34 is very obvious. Let me take another number, 38. 38 raised to 34 divided by 8. What is the remainder? Again, straight away I can put remainder as 0. Why? Because what is 38? 19 into 2. So 19 raised to 34 into 2 raised to 34 divided by 8. What is 8? 2 cube. This part is going to get completely cancelled off with the numerator. I'm sure you have attended the basics of mathematics session. In case if you are not very clear with the basic of mathematics, every day afternoon 2 o'clock sessions, right? So I have explained all this point over there that 2 raised to 34 is completely divisible by 2 raised to 3. So again the remainder over here will be 0. Shubhankar, why will I apply Euler here? Yeah, you can apply, but then the simple question that you would have solved in 10 seconds, you are going to spend about 2 minutes in that, because the moment you apply Euler, it will take some time for you to figure out. Okay, so if you can think of these things, that 8 is 2 raised to 4 or 3, 81 is 3 raised to 4, it would be very handy. And that's the reason I always ask you to remember the powers: 1 to 25 number squares, then 1 to 10 number cubes, then powers of 2 raised to 1 to 2 raised to 10, then 3 raised to 1 to 3 raised to 6, 5 raised to 1 to 5 raised to 6. This is precursor to your CAT preparation. You must remember that. Are we all clear, guys? So this is how we can solve this question, right? So now let's quickly discuss. If you want, you can note down this point and then we'll discuss concept of cyclicity. Next 20 minutes, cyclicity. Beautiful concept. I'm sure you will really enjoy it, guys. Hi Hishu, I just saw your comment that you have some doubts in that, in this question. Okay, let me explain once again. The question was 48 raised to 48 raised to 45 divided by 81. See, what I'm saying is 48 is nothing but 16 into 3. So this power 16 raised to 45 into 3 raised to 45, because 16 threes are 48. So I've just rearranged the terms of the numerator. Divide by 81. What is 81? 3 raised to 4. So please remember 3 raised to 45 is completely divisible by 3 raised to 4. In fact, 3 raised to 5 is also completely divisible by 3 raised to 4. 3 raised to 6 is also completely divisible by 3 raised to 4. Simple, sir. Because what is 3 raised to 6? It's 3 raised to 4 into 3 raised to 2. So we can straight away cancel off this way, na? Yeah. Okay, fine. So someone wants me to solve this question by Euler. Definitely. Let's see how it works. Just a moment, guys. So the question is 48 raised to 45. Acha, please understand, you can't apply Euler all the time. It has to be a favorable situation. Only then Euler can be applied. Okay, remember this part, guys. So divide by 81. Okay. Now, what is 81? So 81 is nothing but 3 raised to 4. So it is made up of this prime number 3, right? So what is phi of 81? So phi of 81 will be 81 into 1 minus 1 by 3, as simple as that. If you solve this, it will come out to be 54, correct? Can you get this power in the multiple of 54? No, can't apply Euler over here, as simple as that. So Euler is not applicable, because this power, had this power been something like this 54 or even 55, because if it is 55, then I can write it as 48 raised to 54 into 48 raised to 1. Okay, acha, before that, I'm sorry guys, I'm sorry. You can't apply Euler over here, because for Euler this two numbers should be co-prime. Forgot that. What is the Euler theorem? You know, a raised to phi of n divided by n, remainder will be 1, where a should be less than n and a and n should be co-prime. 48 and 81 are not co-prime. There is a common prime factor 3. Yes or no, guys? So done there itself. It's over. Are we clear? So don't apply Euler over here. Fine. So guys, now let's look at how to find out last digit. So let's understand the pattern in the last digit, because we need to complete this concept. We are left with hardly 10-12 minutes, right? So let's go ahead with this one. Everyone, and tomorrow we have practice session based on this concept, and we'll also discuss factorial and prime factorization and all those concepts. So please be there. All the miscellaneous number questions will be covered in that, you know. So कल का क्लास पूरा भेलपुरी बनने वाला है, बट मजा आएगा, चटपटा होगा. Right, so pattern in last digit. So everyone, now stop doing your work and you should be paying your attention here. Okay, let me show you this thing. So 2 raised to 1, what is the last digit? Of course 2. 2 raised to 2, what is the last digit? 4. 2 raised to 3, what is the last digit? 8. 2 raised to 4 is 16, so what is the last digit? 6. 2 raised to 4 is 16, so last digit is 6. Now 2 raised to 5, 32, so what is the last digit? Once again 2. 2 raised to 6, 64, so what is the last digit? 4, right? In fact, if you observe, the pattern in the last digit will start getting repeated. Yes or no? 2 4 8 6, so again 2 4 8 6, it will keep getting repeated, and this is called cyclicity or power cycle. Cyclicity. So 2 has cyclicity of 4. Please remember, 2 has cyclicity of 4, because after every 4 power of 2, the pattern in the last digit gets repeated. Are we clear with this one? Everyone, in fact, if we take another digit, let's take another example. Let me take something like 4. What is 4 raised to 1? It's 4. What is 4 raised to 2? It's 16. So last digit is 6. Here last digit is 4. The last digit is 16. 6. What is 4 raised to 3? The last digit is once again 4. What is 4 raised to 4? 256. So last digit will be 6. After 2 power of 4, the pattern in last digit will start getting repeated. And that's why we can say 4 has cyclicity of 2. 4 has cyclicity of 2. Now, instead of 4, even if you take 14, 24 or whatever you take, you just need to focus on the last digit. So if there is 4 in the last digit, the pattern, the final result last digit will get repeated after every 2 power. So you can say 4 has cyclicity of 2, right? So the same concept can be represented by something called power cycle. I can represent it pictorially using a circular diagram. So let me show you over here. So it can be represented this way. So for 2 will represent over here, for 4 will represent over here. Okay. So for 2, in fact, for 4 will not use circle, will use something like this one, oval. So 2 raised to 1 will write over here and the last digit is 2. 2 raised to 2, let's write over here, last digit is 4. 2 raised to 3, we will write here and last digit is 8. 2 raised to 4, 16, so last digit is 6. Again 2 raised to 5 will come over here, last digit will be 2. 2 raised to 6 will come over here, 2 raised to 7 will come over here, 2 raised to 8 and so on and so forth. 2 raised to 9, this will keep going on, right? So if I ask you what is the last digit of 2 raised to 100, what is the last digit of 2 raised to 100, can I say all the power which are multiple of 4 will come over here, 4, 8, 12, 16 up to 100. So last digit has to be 6. Can you make out this thing, everyone? Yes or no? Have you understood this part? Show me a thumbs up if you have understood. If you have any confusion, just show me that confused smiley or ask me your question, please, so that I can decide whether to give you more examples or not. Fine. So same way, if I ask you what is the last digit of 2 raised to 22, now please understand where will this power 22 fall. So I know 2 raised to 20 will come over here, 2 raised to 20 will come over here, then 2 raised to 21 will come over here. Now this is what you need to figure out quickly. The faster you are at identifying this thing, where will 2 raised to 22 come, the faster will be your answer, the lesser will be the time to get the answer. So 2 raised to 22 would come over here and last digit will be 4. So here straight away I can say last digit is 4. Are we all clear with this concept? Same way, let's check for 4. Let me just use a different sign so that things do not get confused. Let's check for 4. Everyone, pay attention. So for 4, as I mentioned earlier, it has cyclicity of 2. So we can represent it this way. 4 raised to 1, last digit will be 4. 4 raised to 2, last digit will be 6. Again 4 raised to 3 will be over here, last digit will be 4. 4 raised to 4 will be over here. 4 raised to 5, 4 raised to 6 and so on and so forth. So I can straight away generalize. For 4 I can generalize when power is odd, when there is 4 raised to odd power, the last digit will be 4. When there is 4 raised to even power, the last digit will be 6. That's it. आपको कोई भी कुछ भी पूछे, 4 raised to 97, what is the last digit? 97 odd power, the last digit has to be 4. 4 raised to 168, even power 168, last digit has to be 6 straight away. Can we do it this way, everyone? Right. So if you try the same thing for all other digits, you will observe this pattern. So 2 has cyclicity of 4. The pattern in the digit is 2486, 2486. And this is what you need to remember. Please remember this complete table. Please remember this complete table before you come for tomorrow's session. It will hardly take 5 minutes. These numbers are very beautiful. Okay. Same way, 3 again has cyclicity of 4. And the last digit pattern is 3971. Same way, if you check for 7, cyclicity of 4. And the pattern in the last digit 7931, 7931. And for 8 also, the last digit is, the cyclicity is of 4. And this is the pattern. In fact, guys, now let me tell you one thing. No perfect square number ends with 2378. You will never find this digit at the end of any perfect square number. This is the point that you need to write down in that notebook which we have prepared, right? Where we are writing all the important points. So please note down this point over there, everyone. Yup. Are we clear with this? So see, because 2, 3, 7, 8 has cyclicity of 4, these digits will never appear at the second power of any number. If you take any number, just square it and you will not find 2, 3, 7, 8 at the units place. So if I ask you, sometimes you require to use this concept, whether 5, 1, 5, 2, is this a perfect square number? No, can't be, because last digit cannot be 2. It has to be one of this 1, 4, 5, 6, 9 and 0. Of course, it has to be one of this only. 0, 1, 4, 5, 6, 9. Okay. Are we very clear about this? Fine. So let me just show you one more thing here. Let's look at which numbers have cyclicity of 2. So let me indicate with a different color. So see, this 4 has cyclicity of 2, 4, 6, 4, 6. And same way, this 9 has cyclicity of 2, 9, 1, 9, 1. So again, cyclicity of 2. And which numbers have cyclicity of just 1? Okay. So these numbers have cyclicity of 1, 5, then 6. Of course, needless to say, 0 and 1 also have cyclicity of 1. Because if any number ends with 0, you raise it to any power, the last digit has to be 0. You take any number which ends with 1, you raise it to any power, the last digit will always be 1. So cyclicity of 1, right? You take any number with 5, the last digit will be 5. You take any number with last digit as 6, the last digit will remain 6 if you raise to any higher power. Yes guys, have you all understood this cyclicity? Show me a thumbs up if you have understood. And yeah, press the like button quickly. Great. So we have almost completed the number system. Now you need to practice varieties of question, because of course you are sometimes asked tricky question like, the question that I mentioned, 16 cube plus 17 cube plus 18 cube plus 19 cube. Now we didn't apply any remainder theorem over there. Neither Euler's nor that Fermat's theorem, or not any special cases. We didn't try to get remainder 1 or minus 1 also. So these are some tricky questions you will have to figure out spontaneously. Right, and that's why see we need not solve all the questions in CAT exam, or for that matter any other entrance exam. We need to pick right question. If I throw 5 questions of number system in front of you, you should be able to think, you should be able to solve 3 questions out of that, and your job is done. You can say you will fall in that 99 plus percentile category if you are able to do it, right? Okay friends, so here are the questions. Now in next 2 minutes we need to solve all these questions. So 2 has cyclicity of 4. So 2 raised to 96, can I say it will end with, look at this one, 2 raised to 96 will end over here. So 2 raised to 97 should be coming over here, right? So last digit will be 2. Isn't that 2 raised to 97, last digit is 2. Same way 3 raised to 78. So check in the cycle, 3 raised to 1, 3 raised to 2, 3 raised to 3 and 3 raised to 4. Last digit 3, 9, 7, 1 and so on and so forth. So where will this 3 raised to 78 come? Of course 76 is a multiple of 4. 19 4s are 76. So 3 raised to 77 will come over here and 3 raised to 78 will come over here. So last digit has to be 9. This will be 9. Same way 4 raised to 65 odd power. So last digit is 4. And 7 raised to 25, if you solve this thing, last digit will be 7. So these are the answers. Guys, can you solve such questions? Yes, everyone? Let me show you a few more questions then. Now write the answer for, write the last digit in the answer box. Please quickly write the last digit in the answer box separated by a comma. Can I say last digit? Of course will be 0 over here, last digit will be 1 over here. What will be the last digit over here and here? So you need to write something like this one, 4, 2, 1, 0, something like this. This is not correct, of course. So please enter your answer in the chat box. Let me see who gets all correct. See, there is 1 over here. So you know 1 raised to any power, last digit is going to be 1. There is 0 over here. So last digit will remain 0. You don't need to check whether this is 90 raised to 90 or 190 raised to 90, doesn't matter. The last digit will remain 0 only. Are we clear, guys? Yeah. And yeah, thanks everyone once again, because you are giving tremendous support. Of course, we are enjoying this learning. You know, a teacher, a trainer always needs a good student, and you have been extremely kind and sincere. And yes, you are learning very fast. So I enjoy taking this session. I always look forward to that 2 p.m. session, 9 p.m. session, and it's fun, right? And you guys have also been spreading the word like anything. I'm sure very soon our channel will be one of the most popular channel, right? So so 2 raised to 123, this last digit will be 2. Good, Varshini, good, excellent. And this is going to be 6, because 6 has cyclicity of 1, right? So last digit will remain 6. Akash, wrong. Akash, how can you enter 1? Yeah, this is an even number. There is no 1 in the last digit. So what is the cyclicity of 8? If you look at the last digit pattern of 8, it will be 8, 4, 2, 6. 8, 4, 2, 6. This pattern will keep going on. So your last digit should be one of this. Of course, so this power is 3 more than multiple of 4. So it will be equal to 8 cube power. That is last digit is 2. Great, guys. So that's it for today. Now in the next session, tomorrow will be the last session of number system. Okay, maybe we'll have one quiz session in between, and then we'll start with the fresh topic. But before that, on Saturday, let me tell you, mostly on Saturday we are going to have number system marathon session. Number system marathon session. Marathon session where on YouTube, CAT for MBA channel, CAT for MBA channel, when on Saturday. Okay, because on Sunday I'll not take any class on YouTube channel. I'll be taking class on Unacademy platform. So I'll be taking special class on Sunday. So on Saturday I have scheduled this class. We are going to revise everything related to number in about 3 to 4 hours time. 3 to 4 hours at a stretch. Okay, I'll not move from here for 3 to 4 hours. So as you can sit with your munching box. That's perfectly fine, guys. Okay, so what you will teach after number system? Okay, after number system, I'm going to teach permutation, combination, and probability. We are going to complete this important area: permutation, combination, and probability. Okay, in fact, one of our educator, Mr. Akash Pahurkar, is starting with arithmetic from tomorrow at 7 p.m. Okay, so you'll soon find that calendar, right? 20 fun 100 hours, right? Tomorrow 9 o'clock. Every day I'll be here at 9 o'clock. Even on Saturday, only on Saturday, since I'm going to take a marathon session, so I'll announce the time separately. I'll tell you what is the timing, but otherwise by default 9 o'clock, and very soon we'll post the timetable also. Okay.